Mic test, Gorge Dam, mic test.
Speak like the main topics and their names.
I had to jot a couple things down.
And then speaker going to talk, do you know?
I did about 4 minutes,
Oh, really?
5 maybe.
Okay.
Maybe might go a little longer, she'll get
Okay.
back, because she's gonna talk about
Okay.
the archaeology,
Okay,
maybe a little longer.
that's okay.
More slowly, because it has up to 30 minutes, I should look closer. So I get 5 more minutes, 10 minutes, and, okay, so Megan's talking about the archaeology, that's the 10 minutes I was thinking of.
Beautiful.
Heather gets 5 minutes, and then we're gonna have the question. Okay. Should I print one of these for you?
It's okay. And as of now, there are no people here that are using sign language, so we know.
Okay, well, they won't be able to miss
We'll
you.
make it accessible.
Okay, yeah, let's do.
Thank you so much.
Yeah. Hello, Mayor. How are you? Good to see you. I was happy in my hand. We're gonna get started in a moment. Yeah. Good evening, everybody. If you'll find a seat, we'll get going. Good evening. I'm Lisa King. I'm the Executive Director at Summit Metro Parks, and I'm going to lead you through our program tonight. We are happy that you are joining us. We're doing a progress update on all the work that's happening at the Gorge Metro Park as partners continue to work together to free the falls. We've entered a new construction season for the dredging, and that, of course, is necessary before we take the dam down. The fact that this is important work, it continues to move forward, is cause for celebration. We would not be where we are today without the unwavering efforts over decades by a coalition of dedicated individuals and strong working relationships across several organizations at local, state, and federal levels. In the spirit of celebration, we'll share an update with you covering progress made so far during the dredging operations and what to expect as the work continues this year. On the screen, you'll see a QR code that you can use to scan and go directly to the Free the Falls information webpage. This is where you can find helpful background information and all the latest updates. You can go there anytime. So for the rest of the presentation, we ask that you please hold all your questions to the end, and we will have a question and answer period. Now, I'd like to please welcome the City of Akron Mayor Shamus Malik, followed by the City of Cuyahoga Falls Mayor Don Walters, who will both share a few words with you.
Thank you, Lisa. Good evening, everyone. Who is excited? There you go. This is exciting. You know, it really is amazing to be here. You know, this is a project that has been a long time in the making, and now we see the progress firsthand as we go over the bridge. And so I think we're going to hear a lot more tonight, but I want to thank everybody who's a part of it, and I want to thank all of you for being interested. You know, it's also not just important what we're doing, but how we're doing it. And really the collaborative spirit that this project requires and shows, I think, is an indication of how we should work in everything, right? And the City of Akron and the City of Cuyahoga Falls are working hand in glove on this, right? And that's also the same effort that we bring to our folks on the Merriman Valley. That's the same effort that we want to bring to other areas. And so, you know, that is the spirit at the local, state, and federal level that we need to see from government, a government that's focused on doing big things and getting things done. And so I'm so glad that this project is continuing in a tumultuous, chaotic world, that this project's continuing. I have huge thanks to all of the partners as part of this project. Huge thanks to our folks at the city, folks at the metro parks, folks, again, at local, state, and federal governments, and to our fearless advocate and leader, Elaine Marsh. Can we give it up for Elaine? And with that, it is my honor to welcome up to the stage someone even more excited about this than me. The guy who is excited to free the eponymous Cuyahoga Falls himself, Mayor Don Walters.
Wow, it's happening. And we never thought it would. So there's so many people. Thank you for everyone that helped bring this together. It's really a miracle that this is happening right now. The funding was there, but all the partners that made everyone feel how important this was to get the funding, get going. So Cuyahoga Falls is ready. We're going to take down the barrier, but the upper left picture there, no one alive has ever seen that the way it looks right there. And we're going to see that in a few years. It's going to break down that barrier. You can kayak right into Akron unobstructed. We had this past weekend, we had the Kayak Fest, 25 or more kayakers from multiple states. Can you imagine when this dam comes down, what we're going to have? It'll be the best east of the Mississippi. So this is just the beginning. We're redoing the whole boardwalk. The river is like, it's a magnet. People love water. So now we're going to finally have it unobstructed all the way to Lake Erie. So thank you very much for all your efforts, and we just can't wait to see it.
Thank you, mayors. It means a lot to us to have you both here. Now I'd like to introduce Bill Zawiski. He's going to talk about sort of a project summary and the Ohio EPA's role.
Well, I'm immediately going off script, so I apologize. So I want to kind of others are going to talk about what's going on and looking forward. But now that I can say it's happening, let's look backwards a little bit to this weekend, right? Ramsey, I thought you said this was going to work. Who saw the ducky? It's always good to start with a big duck. Why? That was helping to celebrate this river and the festival that went with it. Who went to the Cuyahoga River Water Fest? Woo! So it started in 2016. Hard to believe it's been 10 years already. That's pretty amazing. And as Mayor Walters already said, it's only going to get better. Can you imagine this when we have a much larger area for those people of questionable sanity to want to go down those falls? So let's kind of look at a history of how we got here. Started with the city of Kent. So anyone from Kent here? They were the first ones. And again, it was partnership with the Ohio EPA and the city of Kent that worked to achieve this. 6 months following that barrier being removed, the fish community above that structure had recovered. Mother Nature, if we give her the chance, is ready. This is not working, Rand. Monroe Falls. Anyone from Monroe Falls? Mayor's here. Thank you. So Summit County, Monroe Falls, and Ohio EPA partnered to get this structure out. Initially, it was only supposed to be removed half, and there was going to be a fish barrier or a fish way to go around it. Well, the good thing was that river, well, I don't know if it was good or not. It was good for us. The river dropped down into the historic channel that it was in 200 years before when that structure first started getting constructed. mayor at the time was not very happy because he thought he'd still have his dam pool. And he said, you might as well take the whole thing out. I'm like, okay. So we had to go back to the beginning, but what an achievement. And now from above Kent through Monroe Falls, we have businesses that allow people to be on that river enjoying a healthy, clean Cuyahoga River. That's pretty amazing. Up, up, up. I thought you, go back one, Ramsey. Please. Cuyahoga Falls. Who walked and saw some of that? That was cool, wasn't it? The dam cam was the bomb. So we are going to hopefully somewhere have a dam cam because we've all talked about that. That was crucial to this project going forward. In fact, that might have been the most important part of the Cuyahoga Gorge project. But we had two structures that were removed, and look at what happened. 2013 we started. In 2016, now we have recreation celebrating a free-flowing river, albeit a little more challenging than you would normally have for a canoe ride. It is another opportunity on the Cuyahoga River, which is a water trail. The Canal Diversion Dam. COVID did not stop this. So Friends of the Crooked River, raise your hands. Thank you so much. This group took on project management. Now, I must admit, it was probably my fault selling it to them that it won't be that hard. I think they would disagree at this point. However, what a collaboration. Again, a group that was citizens wanting a cleaner Cuyahoga, managing a project that was funded and sponsored by the federal government, the state government, and the city of Akron. And now we have this section of river in our new water quality standards is being upgraded from our normal, which we call warm water habitat, to exceptional. That means it's going to hang with the cool kids like the Grand River in being that good because of recovery. So the history leading to where we are today. These are some of our old water quality reports. So if you ever want to go and bore yourself or read yourself to sleep, go on Ohio EPA's website and look up all of our historic water quality reports because they tell that story. But if you look at black and checkered, those are the non-attainment and partial attainment. Look at those percent changes. Back when we first started, much of our river systems throughout the state of Ohio did not meet standards because of things we did to them, not because of what the river did, it's because of what we did. Oh, Ramsey, go back one more. Okay, go forward one more. So one of the cool things, and I think we've talked about it before, Ohio EPA has one of the richest biologic monitoring programs in the world. These are all biologic monitoring sites that we have completed in the state of Ohio. There's over 20,000 of them now. And they represent collection of fish and macroinvertebrate bug data, habitat data, and chemistry data that tell this story. And no other states really do it. And the US EPA used our program as the model to get other states working. So be proud of that in Ohio. And it was our macroinvertebrate index, which is used globally, was developed by a University of Akron graduate. Go Zips. So let's look at a longer story. Go back at the large rivers. Look how much they have improved. So what we are seeing in the large rivers is these dramatic improvements because we are making things better. Chemistry, dam removals. These are streams that are over 500 square miles of drainage. So the Cuyahoga River in its entirety is over 500 square miles. At the point of the Gorge Dam, that river is 336 miles of drainage. And if we look at the smaller streams, and if you can see the print up top, what it basically says is our smaller streams are getting better, but not at the same rate that our large streams are. And why is that? Habitat modification. Included in habitat modification are dams. And so what we're going to talk about today is it's happening. And we're going to go forward and look to what we're going to have. So I am done. Boom. You're up.
Thank you, Bill.
Hey, watch the clicker. I don't trust it.
I'd like to introduce Courtney Winter. She's going to talk about the sediment management process and a project of the overview of the US EPA's role.
All right, good evening, everybody. Thank you, Lisa. As she had mentioned, my name is Courtney Winter. I am with the U.S. Environmental Protection Agency. I'm here. I just want to give a quick shout out to other folks part of the project team that are here, Suze Ligori, as well as Gerardo Cabriello. It's a big project, couldn't do it without the support of others. So today I'll be going over just a couple slides, providing some background information on the funding, the project partners, and just a general overview of the project itself. For folks who have been to these meetings in the past, you might recognize this. Just going through it as a refresher and as an opportunity for us all to get on the same page if you haven't joined meetings in the past. I do want to just say that it's great to see such a good turnout. I feel like this has been a project with a lot of support and a lot of interests from the public, and so it's just great to see a lot of folks here tonight. Okay, so the figure on the left is showing the Cuyahoga River area of concern. And so the boundaries are outlined in like a bluish color, and the project itself is the red star. So this is on the border of the Cuyahoga River area of concern. And why this matters is because in order for the sediment remediation and the dam removal projects to occur, it needs to be within the area of concern boundaries. So this project was identified by state, local, federal agencies, as well as local advisory committees as a critical project that was necessary to address several beneficial use impairments. So there's a list there, the fish and wildlife populations, beneficial use impairment, as well as the degradation of benthos and loss of habitat. So those are all impairments that were identified within the area of concern that were needing to be addressed. And so local, state, federal agencies came together, as well as the local advisory committee, and chose the dam removal project as a key project that was needed to improve these impairments. And you know, as Bill went over, the benefits of having the dam removed are obvious. So looking at that, so once it was identified that the dam itself was a critical project to be removed, the project team also identified that this dam has been here over 100 years and there's a lot of sediment that has accumulated behind it. So in the image, you can see the blue outline. That's the area of what's the dam pool is what we refer to it as. So that's the area of the dredging footprint. And how that was identified once you know, the group came together and was like, okay, before we can remove the dam, we need to remove this sediment. There needed to be some sampling done. So in different phases of the project design, remedial investigation, they went out and sampled different areas within the dam pool to identify the extent, well, I should say identify whether or not contaminants were present. And then once identified that they were present, what was the extent or area that they were located in. And so the dam pool, it's from the dam itself up through upstream areas. So the area that's being dredged is about 1.5 miles. It goes up to, if folks know where the American Legion is in Cuyahoga Falls, that's like the land side point of where the dredging will occur. And So that the sampling identified where exactly the dredging would need to take place, and then the sediment samples also identified what types of contaminants were present. And so that's where they identified the PCBs, the PHs, oil and grease, as well as heavy metals. And it's really important to mention, the contaminant levels that are present within the dam pool are low-level contaminants. And that's fortunate because there's other regulatory programs that come into play when there's higher contaminant levels. You have TSCA and RCRA regulatory programs that can cost more money and it can cost more time. So really beneficial that the contaminants are present, but at least they're lower levels. So they still need to be properly handled and disposed of properly. And that's what we're going to be discussing today. So just a couple other things to note, the dam pool itself. So throughout the dam pool, there's varying levels of water present as well as sediment present. And the actual sediment that's needed to be dredged varies anywhere between 1 to 34 feet. And there's nearly 900,000 cubic yards that needs to be dredged. And this has been quoted in the past, and so I'm going to quote it again, but hopefully it's correct. There's about that volume, if you can imagine, is about 13 football fields filled to the goalposts. So it's a lot of sediment. So I'm going to just kind of skim through this. This is a general overview of the remedial area, but Charlie Stein is going to be up here after me, and he's working with Sevenson Environmental Services. They are the construction contractor, and he has a lot of awesome pictures to show you of the progress that's happening on site. But just a general overview. So I had already mentioned the dam pool itself, and that's just the area that's in blue. And you can kind of see there's like that little red area. That is where the First Energy, Ohio Edison, the previous power plant areas, and that's where they're staging. We refer to it as a sediment staging area. And so all of the material itself, there, if you've driven past Front Street, you've had an opportunity to see the different barges that are in the water. So they're mechanically dredging the sediment. So there's buckets placed on excavators that are taking scoop by scoop of the material out, placing them on a hopper on the barge, and then it's actually piped, hydraulically piped along the High Bridge Trail. So I'm going to try to point, but most of you probably know where it is. Just following along here. Yeah, thanks, Ramsey. So about 2 miles, it's transported from the dam pool itself over to the sediment processing area. And so that's that area near the Cascade Valley Metro Park that's currently closed. There's the area in red. The material itself is piped over there, and we have the materials mixed with Portland cement, which stabilizes the dredge material prior to final placement. So final placement is that like yellow-orange boundary that's on the map. Yep, and that area is actually a previously deregulated dump. So the material will be placed on top of that, and then it will be capped with native soil, and native seed mix vegetation will be planted. Okay, it's important to mention this project wouldn't be here. I think it's been said a couple times from the previous presenters. Because of the efforts from local, state, and federal partners, this project was made possible. So a lot of meetings, a lot of plannings, a lot of design and tough conversations needed to be had to make it to today, to be able to celebrate the progress being made. The overall construction contract award was just over $130 million. So it's a big dollar sign, but that was a lot of sediment. So they go hand in hand. And this project, so it's funded through the Great Lakes Restoration Initiative. That's the federal portion. But the non-federal sponsors, or our partners, they also provided contributions. So underneath the Great Lakes Legacy Act, so going back to that area of concern that I had mentioned, underneath that program, there's a Great Lakes Legacy Act program. And so in order for a project to qualify for a Great Lakes Legacy Act program, it needs to be within the area of concern. And underneath the Great Lakes Legacy Act, we have project agreements. And that's the agreement with the non-federal sponsors that are listed here. We have Ohio EPA, City of Akron, Northeast Regional Sewer District, as well as First Energy Ohio Edison. So they are signatories of that project agreement. They have agreed to provide cash and in-kind contributions that make this project possible. So just key emphasis on the partners, and we wouldn't be here if it wasn't for the local, state, and industry partners coming together to make this project happen. And also, so there's other partners that we work with, including Summit Metro Parks, that have supported this project throughout the years and continue to do so, as well as Ohio Lake Erie Commission. There's the City of Cuyahoga Falls and Summit County have all provided either cash or in-kind contributions. And we also have a U.S. Army Corps of Engineers supporting the project as well. So lots of folks involved in order to get the project where it is today. And this slide is just showing, feel free to take a picture of the QR codes that are on there. We have a link to the Cuyahoga River area of concern, as well as a link to the EPA Cuyahoga Gorge Dam website as well. We post pictures regularly on there just with status updates on what's occurring on site. And last but not least, these are our contact information and an email there as well. If you have any questions, comments, concerns, anything like that, feel free to shoot us an email at that email address. We would be happy to hear from you. And with that, I will pass it on to Charlie for great pictures.
All right. Hello, everyone. My name is Charlie Stein. I am the superintendent for Sevenson Environmental, the contractor doing the dredging. I was here last year, went over kind of more of how we were going to dredge and stabilize and pump and all that. I'll touch on that a little bit as Courtney did, but want to focus more on, like everyone's been saying, a progress update, kind of what we've been completed to date and what we plan to do this year. So with that, we started last May and mobilized to the site. We have two main staging areas. The one that Courtney mentioned, the dredge staging area, is up at Front Street, and the other one's down at Peck Road at the sediment processing area. So it took us about 5 or 6 months to fully mobilize last year. We have a lot of equipment, a lot of infrastructure at the site, so it took quite a bit of time and effort. But as you can see, here's Front Street and the bridge here. Off to the left is our bigger staging area. So we have some parking, a little trailer for our workers there. There is a debris staging area, which is that black square there where we offload some screen debris out of the river. Next to that is a mechanic workshop just to repair our equipment. And then, obviously a dock to get into the river with some of our boats and also an offloading area for that same debris. So on the other side, much smaller area is the High Bridge Trail parking lot. Anyone familiar with the area, which I think everyone is, High Bridge Trail extends right off of that. So making sure we leave that access open for emergencies, park personnel, dam personnel, First Energy for the power lines that are there. So that was important, working with the project partners on that. And then mainly just parking in that area. And you can see the ramp down to the river. Obviously the Front Street Bridge doesn't have enough height for us to get our big equipment through. So any work we're doing up downstream of the bridge was all launched through that little ramp there. So pretty similar infrastructure down at the Peck Road site. Parking, access roads. We brought in some stone. We used some of Heather's shale that she has plenty of. So that was helpful. But another mechanics work shed, another couple trailers for our offices, and our brake trailer for personnel. So, and then right here is the water storage and treatment area. Adjacent to that where there's a little bit more water and a little bigger area is where all the dredge sediment that gets mixed with Portland cement gets pumped to. So I'll get to that in a little bit, but that's where all the sediment dumps into when it's pumped from the river. And then adjacent to that is the area where we store our Portland cement, where it gets stabilized into the sediment, and then from there trucked out into the placement cells, which are, the grass areas out there. And then did just want to mention, you can't see it on the screen, but off to the right of our staging area there is the Indian signal tree. So we put up safety fence around that. I know we got a question about that last year, so still in good condition. We're never back there by it with any equipment, so it's still doing great. So this is the figure that Courtney just showed as well, just kind of reviewing the dredge area, the pipeline down through High Bridge Trail. I'll talk about the bridge here in a second, and then the processing and placement areas. So again, just an overview before we get into a little bit of a breakdown in each area. All right, so High Bridge Trail, so that's where all the dredge pipe is. We actually had a specialty contractor come in who basically only welds pipe. So we had over 60,000 linear feet of pipe that needed to be welded. We could do it ourselves, but it's just a lot of pipe. So we just kind of put them on it, and they were there for almost a month and a half, just welding, certifying every weld, making sure nothing leaks. We did a bunch of leak tests. So this was one of the more involved aspects of the project, was getting this pipeline installed. So anyone who's familiar with High Bridge Trail, it's just a walking trail, hiking trail. So getting any heavy equipment in there is very difficult. Mix that in with the Chuckery Race that is in the area, the overhead power lines, the utility poles, the dam, all that stuff. It was difficult. So it took us almost 2 months from start to finish to get the pipe in, to get the bridge in, which I'll show in a minute. And we had to use some specialty smaller equipment. Wanted to mention this, it's called the Maruka truck. So what it does is it can drive forward down the trail, and we literally just drag the pipe with it. And then when we are done, that cab of the truck spins 180 degrees so you can drive straight out. The cliff there is pretty dangerous, so we didn't want to back up, up and down that trail 100 times. So that worked out pretty well. Again, anyone familiar with the area, there's about 170, 200-foot gap where there's a big ravine that we had to span for our dredge pipes. We couldn't just fill in the area due to drainage and all the historical features. So we had a couple different ideas. There is a wooden walkway there that we were thinking about rebuilding. We actually brought in a couple local contractors to take a look at it. They wanted absolutely nothing to do with it. So some of our crazier ideas were anchors and cables, literally driving anchors into the uphill slope, securing cable to them and tying them to a couple trees to kind of float the pipe over. I don't think SMP really liked that idea, so we didn't go with that. Sheet pile was an idea, but what we ended up going with was a self-cantilever bridge, which we were able to get back there in 20-foot sections. It was designed by Acro Corporation, who designed the bridge, and then we had to design the abutments as well. So the Glynn Group is a group we work with in Buffalo, New York, who does a lot of our geotechnical engineering, who actually designed the abutments. So the only disturbance we did was drive this pipe pile into the ground for the abutments. So those were driven into bedrock about 10 feet, and we placed crane mats on top of them for the bridge to sit on. I have a bunch of pictures. So the bridge itself was about 170 foot long, 10.5 feet wide total. The walkway is about 5 feet or so. You can see the bridge sat on these rollers when we were installing it. And then we literally just pushed it out into the ravine, and the counterweight of the bridge itself offset it when it was pushed out into the ravine. So we had to build it in 20-foot sections, again, just because of the access. So bringing piece by piece back there. Here is the design of the bridge. So there was a 120-foot launching nose, it's called. You can kind of see it angle upward here and here. Again, that was all for the counterweight. So as that was pushed out, and we were landing on the other side of the ravine, that end came off and then the bridge itself sat in place. So here are a couple pictures. You can go through these pretty quickly, but on the left, this is us literally building it by hand. Every nut and bolt screwed in by hand. You can see on the right here, this is the cliff right here. The Chuckery Race was right here. So not a whole lot of room. We brought in a little stone to level the area. And then you can see the utility pole on the other side. So kind of jammed in there. We have built these bridges before, but usually with a big crane that just comes in and sets it right in. So we couldn't do that with all the obstructions. So here are a couple more pictures of just building it. This is the other side, the uphill side. A little bit more room, but still pretty tight. And then here's our excavator literally pushing it out over the edge. So build 20 feet, push, build 20 feet, push until it reached the other side, which you can kind of, I think it's the next slide that has it, but here's just a couple more. You can kind of see that launching nose angled up a little bit. Here it is going out over the ravine. This is the old walkway that I was talking about. So, and then here it is about to be landed on the other side. This was that other abutment that we installed the same way. So one other thing we did have to do on the right side here was we chipped out just a little bit of existing rock just to make it fit. So the height wasn't going to fit, and then the width wasn't going to fit either if we didn't chip just a little bit of the existing rock. So got that out and made sure everything was lined up correctly. And then here it is landing on the other side again. This side was a little bit lower than the other side, so just making it level by placing a couple more crane mats. And then this picture on the left looks a little bit more dangerous than it is. We had a spotter over here keeping an eye on everyone, but we had to take it off exactly how we installed it. So once it hit the other side, take 20 feet off, push, 20 feet off, push. And we landed right next to this utility pole. So this install of the bridge took us about 2.5 weeks. We were figuring more like 1.5 weeks. So it took us a little longer, but it was safely installed. Once it was in, the right side here, we put in these mats for walking, a little safety fence, and then you can see the dredge pipe being installed after everything was in. And then just a couple safety signs, some stairs to get up onto the platform, and then a ramp on the other side since it was a lot steeper. So, and then the pipes were just secured to one side so they wouldn't be moving around. And I believe, yeah, one more picture of it from up above. So yeah, one of the cooler things I've been a part of with this industry. It was very difficult. Like I said, it took us about 2.5 weeks, and you know, we're actually working with SMP to hopefully leave it there long term if everything works out in the end. So they have a new walkway for their trail, but you know, we're continuing to work with everyone on that. So. All right, so once that was in, we were able to start dredging. So just to review, I think Courtney kind of hit everything here, but almost 900,000 yards of sediment coming out. We're targeting about 100,000 of sand, which is in the upstream shallow area. So that leaves, you know, about 760,000 of silty material. As Courtney said, we are mechanically dredging it. So I talked about this a lot last year. It's kind of a hybrid dredging system. So you can see us mechanically dredging it here with the bucket. So that's the mechanical part, but being able to pump it 2.5 miles down to Peck Road, it needs to be slurried. So it gets loaded into that hopper tank. There's some augers in there. It gets mixed up. We're trying to add as little water as possible because on the back end, when you mix it with Portland cement, any water in there just damages the strength. So it's a little bit of a double-edged sword trying to get it to pump 2.5 miles, but also keeping as much water out of it as possible. So that is the picture on the right. The picture on the left here is one of our high solids booster pumps, which helps send the material down to Peck Road. And then eventually the middle photo there, you can see it discharging into the sediment processing area. All right, so what we did last year in the fall, so starting with the sand, we kind of separate them between the sand and the silt. The sand has a little bit smaller excavator dredging. It's the PC 800 Komatsu excavator. We were able to complete about 7,500 cubic yards last year. A little less than what we wanted to in 2025, but we had to work around a rock slide that occurred in January 2025. So it actually tumbled into the river a little bit. So working our way around there and dredging in that area to try not to, increase the rock slide anymore, slowed us down a little bit, but we were able to get past it and get up there and start dredging in the shallower area. So you can see us loading in some sand here. This sand gets separated out separately from what's getting mixed with Portland cement currently. So adding water to this system is okay and actually helps get some of the sand into the system. So 100,000 yards of this sand upriver is scheduled to be completed by the end of this year. Again, we're working our way downstream to upstream just because of how shallow it is in the area. So we have to dig our way in, get some draft, and then come back out and clean everything up. So on to the silt side, in 2025, we were able to complete almost 9,000 cubic yards. We started after the sand system, so a little bigger equipment, a little bigger bucket. We were able to just move a little bit more material last year. But these green machines, they're just excavators, but we call them Cinnabogans. So last year we only had one of them dredging. This year, two of them are dredging. One's upstream of the bridge and one's downstream of the bridge. And this is scheduled to be completed at the end of next year. All right, so what did we learn from dredging 12,000 or so yards last year? Biggest thing with the dredging is the debris. There is a ton of it. Mayor, we haven't found your bike from last year yet, but there is a lot of sticks, twigs, and leaves. So if you see that middle picture there, that is a picture of some of the debris that came off the screen, and the leaf matting is just, decomposed over years and years, and there's actually sediment mixed in with it. So there's clay, there's silt, just stuck to it, and it's hard to get it to separate, which is what we want. The way to do that is to just blast it with water. But again, we're trying not to add water, so that makes it a little difficult. But we brought in what's called an Alu shredding bucket, which is this top right photo here in the red. And it takes all that debris and just shreds it down to less than an inch. So it kind of slurries it a little bit before we put it into our system. We tried a couple buckets of it earlier this year, and it would just clog up our pipe and pump. So the Alu bucket's really helping. So we're setting up now to be able to do that full time. Once it's shredded, we're able to send it to that sand system I just talked about, as those pumps are a little bigger than the silt pumps. And there's another impeller in there that actually shreds it up even further. So any debris that comes off of any dredges now is getting sent back up to the sand barge, and that's just a lot cleaner, easier way to get it down to the sediment processing area. We brought a couple of these scows into that debris management pad that I showed at the beginning, and it's just too wet, too much material to try and handle it there. That pad was made for dryer, stumps, twigs, logs, metal cans, stuff like that we can easily handle that's dry. So putting that back into the system is definitely the best way to go. What else did we learn? So we talked about the rock slide. So just keeping an eye on the environment, really. I know EPA is doing another study on that rock slide to see how we can handle it, if we can dredge more around it, if we can totally remove it. So they're kind of studying that. There was a much smaller slide that we noticed a couple months ago as well. So just keeping an eye on that, making sure our workers are safe, and taking, progress photos of those rock slides to make sure they're not continuing to move. Slope stability near the bulkhead, so kind of more right of this photo, but near our staging area. We took some samples last year to see what material is up against that slope. Originally thought it would be a little bit more sand or clay material that may be a little more solid. It's pretty soft sediment. So just adjusting the dredge prism to make sure that bulkhead doesn't collapse, making sure again everything's safe, and changing the sloping of that dredging. And then finally, just something we noticed was just how fast the river can move when there's a lot of rain, and we've got a lot of rain this year. So just keeping an eye again on our guys' safety. We're monitoring all the turbidity. So turbidity seems to increase during rain events. So just keeping an eye on that during our quality control checks and making sure we're able to continue dredging. All right, so that was last year. This year, with the sand dredging, we've already removed 6,000 cubic yards in the last month and a half. We did change to a larger debris screen to try and filter through some of that shredded debris that I was talking about. So that is helping. And then, still targeting the 100,000 cubic yards this year. So as you can see, this was taken maybe a week ago. The rock slide is right in this area. So we're up past it now. We're really getting up into the shallow area. So the cycle times on the dredging should be a little quicker, should be able to get some better production and get that 100,000 yards completed this year. For the silt dredging, we've already done about 20,000 cubic yards with just one machine. The second machine started last week. So we changed to a smaller clamshell bucket. And we haven't seen any reductions in production, which is good. We noticed when we had a bigger bucket on and just dropping all that debris onto our dredge screen, it would just clog up immediately. So trying to slow down the amount of volume that goes on the screen seems to be filtering through better and helping us with the uptime production. We modified the layout of number 2 just a little bit, just based on a couple of things last year, but we are targeting about 400,000 cubic yards between both of the machines for the silt dredging. That's upstream and downstream of Front Street Bridge, and that comes out to about 1,000 cubic yards every day with each machine. So 2,000 cubic yards per day, which is a lot of volume to move. All right, so all that gets dredged, it gets pumped down to the sediment processing area, gets discharged into this area that we talked about earlier, the sediment staging area, surge basin we also call it, so I might throw that in there as well. But from there, it gets put into this pug mill, that it's called. The blue silo over here stores all the cement. So the cement comes in through this auger extension, mixed in with the sediment, and then again, another auger tank mixes everything up, gets discharged down into here, and then hauled out to the placement area. All right, I showed this figure last year as well. This is just a rendering, but to kind of get an idea of kind of how the mountains, the hills, the sediment is going to look when we're all completed. So this is an overview of that. We'll be grading it with the equipment. We have GPS equipment, and that is based off of the design from the engineers. So all that gets graded out in the field, and then here's just us loading some of that sediment into the trucks to haul it out there. All right, again, going through last year, what we accomplished, and then getting into this year. We were able to stabilize about 6,000 cubic yards in 2025. We tested a conveyor pug mill, which was different from that photo I just showed. Obviously, conveyors are more open and has a chance for the sediment to spill out the sides. With how wet it's been, we just knew that wasn't going to work after testing it last year. So we changed everything over to confined pug mill system, where it's either chutes or gravity fed, instead of trying to run it along a conveyor and have everything spill. Everything's more confined. So we learned that last year. We were targeting about 12% Portland dosage by weight into the sediment last year. That was during no active dredging. So we were able to dry out the sediments a little more during active dredging as we're continuing to pump water and sediment into the basin. The percent solids and the moisture content rises. So we were targeting 12% last year. We were able to create these 8 test plot areas. So those range between 2 and 5 feet thick. And we were able to learn kind of how it was gonna react over the winter. Portland cement likes warmer temperatures to cure and set up with the sediment. So we were able to get that done this winter and kind of monitor how it was performing over the winter. So these pictures here, we were dumping it out in the field, and then you can see this was after it was mixed with Portland, how thick it was. And we are grabbing some samples out of there to test the strength of it. So lessons learned with 2025 sediment processing is all about the moisture on this end. It was debris with the dredging and moisture on the processing. Just trying to get as much water out of the system as we can after pumping it 2.5 miles. So the moisture content range from 185 to 200%. So we made a change to the surge basin here. We added this berm into the system. So this berm keeps sediment down closer to the Pug Mill processing area. So allows it to drop out and the water can flow off of the back into this smaller pit. And then from there, we pump it into our water treatment plant. So again, just trying anything we can to get as much moisture out of the sediment before it's introduced to the Portland. We talked about the enclosed Pug Mill mixing and then transportation. As Courtney mentioned, it's an old dumping site. There's debris everywhere down here as well. There's soft spots. The rain hasn't helped. So it's been tough to try and truck it out to the placement areas. So we tested a pump last week to just pump it from the moment it gets injected with Portland out to the placement cell. That test went well last week. So we're moving ahead to get a more permanent pump out here to be able to pump that along with truck it. So we have the option to do either or. So another thing we learned was just how soft it was out there with being a former landfill and how wet it is. And then obviously learned and continue to learn the strength requirements and how much Portland is needed for the sediment. As I mentioned, the moisture is key. So anything less than 150% moisture, we're targeting 12% Portland. Once it gets above that, we're anywhere between 14 and 16% Portland. So a little higher than initially thought. It is the base layer, so it is going to hold everything on top of it. So it needs to be strong, sturdy. Hopefully, as we come up in elevation, we're out of the soft areas. Any rain can shed off. The wind hits it a little bit more. You might not think that it helps at all, but it really does. And it kind of just drives that moisture out of the sediment. So this year, we have also already stabilized 6,500 cubic yards in the last couple months, or month, sorry. We're still in the pilot study. So again, as I mentioned, just constantly learning more about the moisture, more about the Portland dosage. So we've dredged 20,000 yards. So a lot of it's still in that basin. And we're targeting 30,000 for a pilot study. Once we get that completed, we could talk with EPA, the project engineer, and come up with the final game plan to move forward with stabilizing the rest of the cubic yardage. But that should be completed in about a month or so. And we'll have a lot of good data with all the Portland and strength by then. The production down here is scheduled to start after the pilot's done. So hoping to roll right into that. It goes until really the cold weather sets in. So hopefully Christmas if we're lucky. But there are some temperature restrictions on the stabilization. As I mentioned, Portland doesn't like the cold weather. So but targeting 500,000 cubic yards this year. That's about 2,500 cubic yards a day. So a little bit more than the dredging to be able to keep up with that material in the basin. So yeah, that's the goal this year. And then obviously finish the rest 27, 28. All right, so some of the work monitoring, quality control, I think I shared the same slide or similar last year, but just wanted to touch on, the continued coordination with local stakeholders, our infrastructure monitoring plan. So we're just monitoring everything on the site. The Front Street Bridge, the dam itself, the bulkhead, there's some utilities we're monitoring, the Chickory Race. There's a lot of them. So, everything's installed now. We actually got some pretty good data over the winter on the Front Street Bridge. Talking with Summit County engineers, we actually installed a couple more monitors. So nothing's moving or anything, but just to be cautious, we added a couple more monitors. So again, just working with local stakeholders and trying to get the best data that we can. All our equipment out on the water has GPS capabilities, so the operators at all time know where their bucket is, what elevation they're at, what elevation they need to get to finish dredging. All that's tracked on a computer right in their cab of their machine, so they know exactly where they're digging. So we compare that with the hydrographic survey. Here's a picture of our survey boat. So that kind of quality controls what our GPS is saying, because obviously GPS isn't 100% accurate all the time. That's why we do the survey checks. The surveys are a lot more accurate. So just doing those almost every day, honestly. And then we have a third party come in to QC our work. So, and then we mentioned some of the environmental monitoring, like the turbidity monitors. We have 3 of them at all times while dredging. So we know the turbidity of the river. All right, schedule. So we completed mobilization last year. Everything's set up. We began dredging and system shakedown as we went through in the fall of last year. And now it is time for the full production dredging with 3 operations. So that will be ongoing all this year, all of next year. The goal is to complete dredging December 2027. Pending any additional dredging, which just may be anything that flowed in from upstream, or if there's a little fluff layer left at the bottom that we have to get. But we should be done by the end of next year. And then all of 2028 to finish the placement area, make sure that's all graded, get it covered. Courtney mentioned the native seed. Get that established with the cover crop and make sure everything's growing, no erosion, stuff like that. All of 2028 and hopefully out of here at the end. Work hours, public impact. So work hours are 12 hours a day, 6 days a week. Sundays are reserved for maintenance. So we have some small crews come and fix the equipment, do some services, stuff like that. So we can continue to run and stay on schedule. We mentioned the dredging between March and December with the winter shutdown due to the Portland cement. So this year it was January to March, just with the temperatures. So probably plan on that again this year. And then some of the other monitoring that we're doing, air monitoring, dust mitigation, we haven't had any issues with dust so far, which is good. But we have a full-time water truck on the site to wet down the roads if there is any issue with dust. And then odor hasn't been an issue at all either. So we had that on here from last year, but to date, there's been no issues with odor. All right, last slide. I think we mentioned it a bunch, but again, wouldn't be here without the project partners. So obviously the US EPA, but City of Akron, Cuyahoga Falls, Ohio EPA, SMP, First Energy, Ohio Lake Erie Commission, they've all been great to work with. They obviously want to see the project succeed, and so do we. So that team has been working great together. There's been, and continues to be site visits from everyone, future planning for future work. We talked about the protection of the local resources, the chuckery, some trees in the area. So just continuing to work with them. We have weekly meetings to make sure everything's in line. So yeah, wouldn't be here without them today. So appreciate all their help. And then just wanted to touch on the community. That's why everyone's here today. So hopefully long term, we're leaving the community in a better spot than when we got here. But while we are here, trying to be involved as much as we can and make any small impact on the community we can. We hire 25 to 30 local union employees, so they have also been great to work with. We might hire a couple more here as we continue to ramp up into full production. We also travel with about 15 to 20 Sevenson personnel who come from New York, Pennsylvania, Michigan, Wisconsin. So we're all staying locally. I know some of us stay here, some of us stay up in Stowe. So we're staying locally. We use local subcontractors when needed, local vendors. Shops is a loose term. I mean, that's mainly pointing to this picture in the middle and just kind of pumping some money into the local bars, but, and then I did the Free the Falls podcast. If anyone hasn't heard that, go listen to it. It's great, with Mike and Elaine and SMP. So that's out there. And then, a bunch of our sites each year try and donate to charity or do a food drive. So this year, last year we partnered with Akron Canton Regional Food Bank, dropped off, about 360 pounds of food and, some cash that equated to just under 2,500 meals for the needy. So, like I said, we're only here for short term, but we hope to leave an impact while we're here and as we're gone. So thank you. I appreciate the time, and we'll get the project finished up in a couple of years here.
Thank you, Charlie and Courtney and Bill. Don't we have amazing people working on this project? Yeah. Okay. All right, so some general updates. Here you can see kind of what the plans are for keeping in touch and so forth. Oop. Uh-oh. There we go. Also wanted to show kind of our thoughts on closures and so forth. Sorry, I didn't really think about talking through this with you, but at this point, of course, the Chuckery area is closed. Gorge Metro Park is open. The Oxbow area of Cascade Valley is open. The plan is to not have to close Gorge Metro Park, although we are closing portions of the trail as we work on it. So those will be, there will always be updates on our website for that. Let's see. There we go. Got it. And I have one more. Next up, I would like to introduce Dr. Megan Schaefer. She's Summit Metro Park's Cultural Resources Supervisor, who will share more about the archaeology work our conservation staff is doing related to this project. Welcome, Megan.
Hello, good evening. So I am Megan Schaefer, as advertised. I'm going to talk about how we monitor historic and archaeological sites in Gorge Metro Park during the sediment remediation and dam removal project. So I'm going to do this by giving some answers to frequently asked questions that I get. So the first one is, what historic sites or structures are in Gorge Metro Park? And unfortunately, I don't have time to talk about all of the cultural resources in the Gorge, so I'm just going to talk about some of the things that meet a certain set of criteria, and those are historic properties. Historic properties in this context doesn't mean just anything that's older. It means it is a specific label that's applied to, as it says up here, any pre-contact or historic district sites, buildings, structures, or objects that are eligible for or that are already on the National Register of Historic Places. And this is outlined in the National Historic Preservation Act. So the same way that you would look to see how a project of this nature would affect threatened or endangered plants or animals, we also ask, what are the effects on these rarer historic properties as well, these sites? When we started the sediment remediation and dam removal project, we assessed several historic sites and structures throughout the gorge, and 4 met that bar of being considered to be historic properties. So they were eligible for, or they were already on the National Register of Historic Places. So you see the 4 here. And of those, only 1 had the potential to be impacted by the project. All the others could be avoided. So the one that could not be avoided was the Chuckery Race, which you've already heard that a couple of times today. And I think Charlie from Sevenson knows that if you say Chuckery Race 3 times in a row, I appear. So it is along the footprint of the High Bridge Trail. a lot of the Chuckery race is on that footprint. This is the Chuckery race. It is on the National Register of Historic Places already. It was constructed between 1840 and 1844. And a race is a channel or a canal that's built off of a main waterway that diverts some of the water flow for the purpose of powering mills or machinery. So it's a piece of water infrastructure that is designed to power industry. And this particular one was designed to power a new city that was going to be called Summit City, which would have been around the area of what's now North Hill, kind of in the southern portion of what's now North Hill. Because you probably know this because we don't have a town named Summit City. It didn't work. It was not successful. On opening day, the newspapers reported that the water came slowly as if it had lost its way. So it wasn't very successful. Remnants of the race can still be seen today, however, and it is called the Chuckery because of an old quip about Summit City, which is, the joke is, what's the population of Summit City? 10,000, one man, and nope, and 9,999 woodchucks. So any dads that are in the audience, if your jokes are legendary enough, they can last for centuries. How do you protect something that is within the project footprint? And this is really smack in the middle of the footprint. We developed a plan for monitoring the resource for starters. So the first step was doing precise documentation of this resource, which meant photographing it. And we also did 3D photogrammetric modeling of it. This is very difficult because it's already been mentioned, this is a very steep area. And the Chuckery, what's left of the Chuckery, is in those very steep conditions on the downslope of the High Bridge Trail. So we actually had staff who were rappelling off of the side of the slope, and they were taking imagery. Not me. I was standing above them going, "Looks good. You're doing great." That modeling provides accurate imagery of the race remnants, of all the remnants that are still along the High Bridge Trail. So we have a good before picture of the race in case anything does happen to it. And then during the project, the race is actually being monitored by vibration monitors. So thank you to the contractor, Sevenson, for setting those up, as well as cameras, which allow us to keep an eye on the resource as well as the activities that could impact it. So we work with the US EPA and the project contractors to determine what's going on if one of those vibration monitors does go off. And we did actually have this happen early in the project. When they were putting in the new bridge, they were prepping the site for that. The vibration monitors did go off. I was contacted. We did a site visit. We discussed it with US EPA. We discussed it with Sevenson, and we were able to work together to determine how to move forward with the project and get completed what needed to be completed without causing any further alerts. This is the biggest question that I get probably is, what kind of stuff are you finding? I bet you're finding all kinds of cool things. If you like shoes, plastic trash, golf balls, and pieces of bottle glass, then yes. Most of what we're finding are things that we would not curate in our collection. But what happens if you find something cool or important or historically significant or meets that bar to be considered a historic property? We actually have a conservation plan that we developed in coordination with the State Historic Preservation Office we use that in case something turns up that we would want to curate. So how we approach that curation would depend on what the object is. Some things that have been submerged for a long period of time are notoriously difficult to conserve and to curate because they're subject to deterioration as soon as you take them out of water or mud. Other things would probably be bulky, or we wouldn't be able to curate them because of their size, or it just wouldn't be feasible. There's a possibility that we would share photos of them or do 3D modeling of them, however, to keep a record of these pieces of history, and as well as to share them with the public. So this is another question that we get a lot, which is, what if you find a body? First and foremost, if a person were to be found, the contractor would call the local authorities and Summit Metro Parks Police, who would follow all the local and state laws regarding the discovery and treatment of whatever would be found. We also have, so you see up here, we also have an inadvertent discovery plan. If this is for anything that is historic or pre-contact or prehistoric, if anything were to be found of that nature, we have this inadvertent discovery plan. This is also developed in coordination with the State Historic Preservation Office. It provides guidance for the unanticipated discovery of human remains or historic or pre-contact artifacts. So it's primarily for assessing if that unanticipated discovery would be Native American in nature. So I would, if anything were to be found, I would follow the steps that are outlined in this plan for assessing whatever is found, contacting tribal nations if we need to do that, protecting what is found, and making sure that US EPA, Sevenson, and some metro parks and the project partners are all working together to determine how we would be moving forward from that. Can this really work? It can. We actually had an unanticipated discovery that was made out in the sediment remediation area earlier this year. So this is actually what you see here. This is a grave marker. It's actually a footstone for a grave that was found in that sediment remediation area. So the project contractor immediately called US EPA. I was notified. We knew from the cultural resources assessment of the area that this had been used as a landfill, and that there weren't any burials or cemeteries in that area that we were aware of. We did a site assessment of it as well, though, and based on its location, based on the surrounding soils, this told us that it wasn't in its original location. So then we started researching, and with some research, this was mostly my colleague Charlotte Gintert. She researched this and was able to find the grave of the person that it was memorializing. So this is Charles P. Lewis. He was buried with his spouse in Mount Peace Cemetery, and we worked with the cemetery to get the records of this burial plot. So he passed away in 1923, which is what is on this stone here, and was buried with this original footstone. And then in 1953, his spouse passed away, and the cemetery records show that the current marker that's up memorializing both of them was installed at that time. So probably the marker, the footstone, was removed at that time. And somehow it made its way to this area of Peck Road, which was that dump that was operating as a landfill at that time. So this was a case where we were able to coordinate with our project partners and the contractor, and we were able to actually return the footstone to the cemetery, who reinstalled it at the grave. So it has gone back to memorializing the decedent where it was originally intended to be. So it's a great example of everybody working together to make sure that that marker was treated correctly and respectfully. And that's how I would expect anything that's of this nature going forward to be handled by everyone involved in the project. And that's all I have for you.
Thank you, Megan. Next up, we have Heather Uliger. She's Senior Engineer at the City of Akron, and she's going to give you an update on the North Side Interceptor Tunnel.
Thank you, Lisa. Do I have to do something? Okay, good. I don't. As Lisa said, I'm Heather Ullinger. I work for the City of Akron Engineering Bureau, and I'm here to give you a very high-level overview of where we're at with the North Side Interceptor Tunnel project. Okay. This project is kind of related to Gorge in that it's an improvement to water quality, but it's actually part of our consent decree in Akron. And the purpose of our consent decree is to reduce combined sewer overflows to our receiving waterways. In this case, it's the Cuyahoga River. And one of our overflow locations happens to be right by Front Street Bridge. So we always talk about these projects together because they're on the same schedule. And as you can see on the map, which I'm not ready to advance to yet, but they're sharing space as well. So we've done a ton of planning to make sure these projects work smoothly together. And so it's oftentimes convenient to talk about them both at the same time. But I did want to keep this slide up. This is right from our consent decree. And this is the design criteria for the tunnel project. And the bottom line is our water quality improvement is we're reducing combined sewer overflows to the Cuyahoga River, specifically through this stretch of river that we're talking about here tonight. This project is one of 26 projects, so it's the 25th of 26 projects in our consent decree, so we are almost done. We're very excited to almost be done. It's been a long time coming. So move on to the map. Okay, so our tunnel, the main line tunnel is the red line. It goes from the Chuckery area of Cascade Valley Metro Park to Front Street. So that is the tunnel that we oftentimes talk about as the tunnel. And that is capturing combined sewer overflow from 3 combined sewer overflow locations. And so instead of those overflows occurring to the river, we're capturing those and those are stored in the tunnel. We have another tunnel that runs north-south that is capturing an additional overflow location called Rack 32 that is to the southern portion of the project site. So those tunnels are working together. They both end at the orange dot. That's our tunnel diversion structure, which is in Chuckery Metro Park. And if you remember Courtney's map, these maps look very similar. And so you'll understand why we talk about these together. Okay, so I said I was going to keep it simple and keep it high level because we are near the end of our project, so a lot of our stuff is done. This is the completion of our mainline tunnel. This occurred in November of 2025. So once the tunnel boring machine breaks through, we have a photo op, and it's a very exciting day for us. And then, remember I said we had another tunnel, this is our Rack 32 tunnel, and it is complete as well. And then we had another tunnel. This is how our tunnel system drains out to our existing sewer. So I said that the tunnel system stores flow during an overflow event. Well, it has to drain back out to the sewer system, and this tunnel serves that purpose. And then we have another tunnel. So it's like 4 tunnels in one. So this is the tunnel overflow conduit. If you've been across the river at Babb Run Park, you may have seen this. These pipes we will overflow during extreme conditions. If we didn't overflow, we would be popping manholes, which is not good. We would be flooding basements, which is not good. So we do need an emergency relief point. The good news about this is we're consolidating all our overflow locations. So we're removing 4 overflow locations, and this will just act as an emergency overflow in those like catastrophic storm events. So what's next? No more tunnels. Lots of structural concrete and rebar. We have to abandon the existing sewer, which is in Highbridge Trail. That's from Front Street to Main Street. So that will be filled with grout. We'll be coordinating with US EPA and Sevenson because that sewer is under where the sediment pumping lines are placed. And then we'll tie in all of our sewers, and the tunnel will start receiving flow by the end of this year. And then our final restoration is due to be complete next July. And that's it. We do quarterly updates on our website, which is akronwaterwaysrenew.com. So we usually do those seasonally. So check out the website. We have some cool videos if you have more interest in learning about the Northside Interceptor Tunnel project. Thank you.
Thank you, Heather. We're going to go to question and answer. So if our speakers would like to come up here, we've got two people with microphones. So if you put your hand up, they will bring you a microphone and we'll do our best to answer your questions.
Question for Charlie. There was discussion of beneficial reuse of the sand. How has that gone?
Not as planned. We have dredged, what have we dredged? Almost 15,000 yards to date, testing it in 250 cubic yard piles, and nothing has passed for residential standards. So it's all staying on site. We're going to start incorporating it into the Portland cement and mixture into the sediment. So it'll all stay on site and be capped like the other sediment.
I don't know who addressed this too, but have you done any studies on the impact on wildlife? Because we've seen a lot more deer in town than we had prior to that. So I don't know how this is affecting that.
So the US EPA had a research group that is studying all kinds of things. They radio tagged fish. So you've seen some information on that. Folks are studying the spiders. There's an actual person studying the spiders and the impacts of this on the spiders. So yeah, the wildlife is being looked at and why the deer are hanging out. Do you have hostas? I have no idea. I mean, there's obviously a lot of activity going on in that park area. And if I was a deer and I didn't like the noise, so it's probable that they may be evacuated from there, but then they make lots of baby deer.
Hi, my name is Cynthia. And my question I can't even articulate well because I'm not informed in the lingo. But I live in Akron and I love the parks. Thank you, Lisa, for all you're doing for the parks. My concern remains with Cascade Valley. I'm not understanding exactly, and I do mean exactly, how this sediment is going to be stored and how secure that storage is so that we will not have to worry about contamination because of shifting, or I just don't know how to ask the question. Perhaps that's sufficient for someone to respond. Thank you.
Go for it.
Yeah, that's a good question. So I think the question was the long-term storage of the dredge sediment in the Chuckery area or the Cascade Valley Metro Parks, and what that means for the future. And so I guess to answer that, in previous phases of the project, going back to feasibility studies, the project team as well as the contractors looked at, it's referred to as leachate testing. And so they looked to ensure as designed that there wouldn't be any impacts to like groundwater or due to runoff, anything like that from the surface runoff, that any contaminants would impact that area. And so what actually happens as part of that stabilization process, so the Portland cement that we've mentioned, when it's mixed in with the dredge sediment, it's actually stabilized, and it's not only attaching to the material, the dredge material, but it's also combining to the contaminants as well. So it's going to be stabilized in place. And so that's why Charlie had shown those images of the different placement plots of the dredge sediment. There's a lot of testing to make sure that it's meeting strength requirements and meeting the specifications in the design to ensure that it's not causing any future impacts. So lots of studies done and lots of testing and evaluating in this current phase of the project to ensure that it is remaining safe. And I don't know if you have anything else.
Can I- oh, I have to go. Oh, yeah. Dr. Capers, I'd also add, those are the same questions Metro Parks had because these were the experts. It wasn't us. So our concern was, starting with the end result, which is really hard to imagine, what is this going to look like? How is it going to stay put? Will it look natural? All those questions that I thought the public might also want to know. Certainly we wanted to know. So in the mixture that they add to the sediment, it makes it so that it's not so runny. You can bulldoze it, you can shape it. So our understanding became when we understood, okay, so we're making a landform, with this that will eventually grow something. Okay, that's a good place to start. Then we did a lot of iterations of what these landforms could look like that would hopefully mimic what you see in Cascade Valley. It's a rolling landscape. It's got some slope to it. So, to the best of our ability with this material, it will end up in a form that will feel more natural, especially once it gets vegetated. So, we were kind of thinking similar question to what you ask. How is it going to stay put? We understand you're taking a very watery sediment. How does it become something we can bulldoze and shape? So they handle all of that. And I wish I could say I knew what it was going to look like. We all want a crystal ball, what the whole area is going to look like when we're done. But we have the makings of something that will give us a very beautiful setting in the end.
And the root system of whatever it is that we plant will survive whatever is going into this space.
That's what we believe. That's what we're told. And that's why the percentage that we're mixing in, those lower layers of these landforms might end up having a higher percentage, 14 to 16%. But as we go up, we want to reduce that. And I think the target is 12%. So in the overall, it's really meant to just firm it up. Does that make sense?
Yeah.
Yeah.
So like Lisa was saying, once that is all completed with the sediment and the Portland cement, in addition to that, on top of it is another 1.5 feet of virgin soil. So it's actually working with SMP from across the street. So it's coming out of that park, going on top of our dredge sediment, and then again, working with SMP, getting a native seed, a good seed mix that will take a couple years to come in, but it will be, native and look hopefully like the surrounding area. So we'll plant some interim seed to make sure it grows fast so there's no erosion, but hopefully, like everyone's saying, in the end, it'll look like the surrounding landscape.
Do you have a schedule as to when the actual dam deconstruction will start?
Yeah. Go ahead. Okay.
I was nominated to make the commitment. So the sediment dredging will occur through the end of 2027, and they'll be working on their restoration in 2028. So we would hope to start the dam removal in 2028 and then complete that by 2030.
I want to retire before.
Nobody's going to.
You jokingly mentioned about finding the mayor's bike or looking for the mayor's bike, which kind of led me into another thought, which would basically go to two of your presenters, dredging and inadvertent discovery. During the process of dredging, they're pulling out buckets full of things and going right into like a grinder type thing and grinding it all up. Is there anything like preventing, especially like along the bridge and so forth, where people will be tossing things over, anything that would be possibly locating like weapons or anything that had been thrown or discarded there, or actually, possibly fell upstream and came down there, anything that would like locate these items?
Yeah, so when we take a scoop out of the river and put it into our system, the first thing it hits is a screen. So one of the screens is 1 inch, the other is 3 inch. So that screens off any oversize before it gets shredded, grinded, anything like that. So our operators know if anything hits that, we have to dump it anyway. So they look at it, make sure there's nothing there. If there is, obviously get a hold of the partners.
So once the dam comes down and the water level is lower, what happens to the banks? Is there a restoration plan for the sides and the banks? And I'm sure you experienced that when the other dams came down.
So one of the cool things about the gorge, now, obviously, because we don't know, we can't say for sure, but it is in bedrock. So things that we've worried about on some of the other upstream dams, such as erosion and movement, are not as big a consideration here because that river is already locked in. Now, what areas will be exposed, what areas will gain vegetation, I have no idea. Because, I mean, this has been submerged and any plants are gone. So we're all going to experience it together. But the good part is, erosion-wise, we're not worried about it because we have this bedrock channel.
I'd seen a rendering of the dam and creating some type of a lookout. Is that still part of the plan for in the future?
Oh, Suicide Hill? The attorneys decided the word attractive nuisance applied here, so that was initially something that was thought about from a viewscape. But I think where we're going now is, Heather says, new way.
So my wife and I frequent Front Street, and we look down in there and we notice this rock slide, and I'm fascinated by that. It's really big. In case you haven't seen it, it's definitely worth a trip down there to look. I just want to know what's going on. What happened? Is it all natural or what?
Yeah, but where to come? So it's all natural. So, I mean, at this point, remember, water level hasn't changed, activity hasn't happened. So this is just part of rock breaking and sloughing. And that leads to not having, so we don't want that to impact our project, which is why US EPA is doing all these additional studies.
Thanks.
Yeah, the actual rock slide was discovered in January of 2025, so last year. So it was before anybody was on site. So definitely not impacted from the project itself. And and ODOT's aware, and we're coordinating with them as well on the evaluation that we're doing. The investigation that we're doing, we'll share the information that we've gathered with them and vice versa. So we're all coordinating.
How high will the Front Street Bridge be above the new water level after the dam's down?
So what's it now? What's that water level?
908.
What that? 908. So it's like 15 feet above. We're trying to do math here. We need an engineer. So 30, probably 50 feet, give or take. 50 or 60 feet is a consensus.
And they'll keep the original bridge, right? There's no intention to rebuild the bridge?
No additional comment at this time.
No.
From Cuyahoga Street, you can, if you're looking across the area that all this sediment is going in, the far embankment recently has been stripped, has been clear cut. I'm assuming that's where the pipes are coming down.
No,
It
sorry,
seems like it's such a large area to clear out. I thought maybe something else was going on there.
So that goes back to the other question. That's where we're getting all the virgin material to cover our dredge sediment. So it just gets excavated right out of the bank. So we had to clear the trees and we'll start digging in there probably later this year.
Courtney, I believe you had on your first slide an area of concern that was actually pretty large and north of or further downstream from this project. Just curiously, what is that area of concern?
Yeah, so that's a great question. The area of concern, so this was a designation that was given to 30 or so, 35, I think, of areas of concerns throughout the Great Lakes Basin. And so there's 25 that are remaining. And Cuyahoga River area of concern is one of them. And those boundaries were originally set back in late 80s, early 90s. They've been working, through working with local, state, and other federal partners. There's been expansions to them, just depending on like further evaluations, further assessments of the area. Specifically, I guess the location further south of the Gorge Dam where it's located. I can't speak to like projects that are happened in that area or the extent of the area of concern, why that boundary was chosen. But like projects such as this, like the sediment remediation project, as well as the actual dam removal project, because it's within that area of concern boundaries, we're able to utilize the Great Lakes Restoration Initiative funding and that Great Lakes Legacy Act program to get the projects done. So I can't speak too much to the like area of concern in general, but that's how this project kind of landed in it. I don't know if others know more about that.
Does that answer your question? Then we're good.
No question, just a thank you.
You're welcome. If there's any questions, this is your time to close it out.
Got one right here.
Uh-oh. You're jumping out too soon.
I saw that the city of Cuyahoga Falls was listed as a partner, and I'm wondering what the city's contribution has been financially or otherwise.
Would you like to speak there? Okay, directly from the mayor. Thank you, Mayor. So 50,000 in financial contribution and lots of in-kind. So we've had many meetings in their facilities. They've come to the table and been at the meeting and really, it's been sort of a brain trust of a lot of concerns at the beginning, and then the expertise came in, and the folks from the city of Cuyahoga Falls and the city of Akron have been great, just working along with us, because not all of us can, give as much money as we certainly would like to, but we can give in other ways. And so both cities and Metro Parks have been sort of in that realm.
Right here.
Hi there. Can you explain a little bit, like I understand the improvements in for water quality and wildlife habitat in the dam pool. Is there going to be benefits downstream once the dam is removed?
Good question.
So in general, what we've seen on these other dam removals is the downstream doesn't change at all. So the point of doing engineering work and look at what goes on is we want to address what's going to change in the dam pool. And from an engineering standpoint, the big things that change are obviously the height of the water and then the speed at which the water moves from point A to B, because the dam pool is just water goes there and sits. Once you take that structure out, now water resumes its speed. And in the case of the gorge, that's going to be pretty energetic because you have this height difference. So downstream, once this is all done, it should look no different than it does now, except the view looking upstream will obviously be altered. You won't look at a wall. You'll see the historic falls in whatever form they remain. Go for it. No, so that's the thing. Even though this is a big dam, it's not a flood control dam. So it's a big low head dam, and they do nothing to control water. So anything downstream will be exactly the same. Upstream will change. So in one way you can think about this, we get more flow, which we're getting these changing rain patterns. By removing the water, we make space for more water. So that channel that's now currently full of water will have more space to hold water. So downstream flooding will be no different than it is now and whatever the future holds. Uh-huh. See, that's why we got 5 minutes until you're getting out.
All right, this is my final selection.
Last question, thank you.
So with the picture that you have on Free the Falls, is that like is that a rendering of what you believe the falls might look like once this goes away? Is it really going to be a falls that folks can go down in like a raft or a kayak, or is it going to be more of a rolling falls, or is it going to be like a sharp falls?
Well, we are asking all those same questions, except that that's a photograph, a historic photograph of the original Cuyahoga Falls. So, boy, we hope it looks something like that. We know the dam was built out in front of it, but the dam has a giant base. So we're all hoping that it resembles that. And you know, what kind of water flow flew and over that dam, we have no idea. So we're all really excited to just see what it is when it's done.
Great. Thank you.
Thank you, everybody, for joining us.